Welcome to Study Loop.
Okay, so for this one, we are going to consider a sample of stars that are given in the diagram. And we're going to assume that these stars are at rest, okay? And with the sun located at that position. And for part A, I want to sketch the velocity vectors associated with the apparent motion of each star as seen by the sun. And label the apex and antapex on your diagram. Okay, so... And then, part B, sketch the radial velocity and transverse velocity components of each star's apparent motion. Okay. So for parts A and B, let's go ahead and draw a diagram. So here it is. And I have different locations. I have a location A, I have a location B, location C, location D, location E, location F, location G, and H. And of course, the sun is right here. Okay. The first thing, let's go ahead and label the apex and antapex. Well, antapex is going to be all the way over here. And apex is going to be all the way over here. And how do I know that? Well, let's draw the vectors to prove it. Alright, so let's go ahead and do those velocity vectors to prove that this is indeed antapex and this is indeed apex. A is going to go all the way right here. B is also going to go right there. C is also going to go right there. D right there. E right there. F right there. G right there. And H also right there. So they're all going to the right, like that. Now the radial and transverse velocity components, well, all you have to do is vector addition. So points A, C, E, and G will not have any radial velocity or transverse velocity components. However, points B, D, F, and H will. And they are going to be these guys. Right here. So those little dotted ones. Like that. Like that. Like this. And like that. Okay. Let's move on to part C. Describe how you might locate the apex of a solar motion given the radial velocity data of such a large sample of stars. Well, stars near the apex. Remember, apex is for approaching. Have the largest negative radial velocities. And stars near the antapex, remember, receding, have the largest positive radial velocities. Okay? And D, how would you identify the solar apex from proper motion data of stars in the solar neighborhood? Well, remember that stars that are at the apex have no measurable proper motions due to solar motion with respect to the LSR. But as you consider stars that are farther and farther from the apex, but away from apex, your proper motion starts to increase. and appears to move directly away from the apex. Now, stars 90 degrees to the apex have the largest proper motions, and stars near the antapex appear to be converging at the antapex. So that's how you would do it.